Hello, I'm Paul Belflam and this is Industrial Organization. This presentation is about quantity competition. We want to analyze quantity competition, first starting with a duopoly where the two firms produce differentiated products, and then we will generalize to an oligopoly and consider the case of homogeneous products and asymmetric and further asymmetric firms. This is based on Chapter 2 for the specific model we used, and especially on Chapter 3, Section 3.2.1 in the textbook. Okay, remember we are using this unified model because our goal is to compare price and quantity competition. We've addressed price competition in a previous presentation. Now we look at competition in quantities, which is also called à la Cournot, because we follow the model of Augustin Cournot. In our specific example, remember this is how we write the profit function of firm 1. We make the same simplification as we did for price competition. We set b is equal to 1. We can do this without loss of generality. And we consider d, the measure of the substitutability between the products, as anything between 0 and b. b is equal to 1, so anything between 0 and 1. Just a technical note here, because we're considering the inverse demand, in this case we can use this model to consider all cases from independent products, d is equal to 0, to fully homogeneous products, d is equal to 1. Okay, so we proceed exactly as in the same way as we did for price competition. We can use the fact that this is a continuous game to use calculus in order to derive the best response function of the firms. So we start with firm 1. Here it's its profit function, which is of course written just as a function of quantities. Okay, we've got, as before, a product of two functions of u1. We use the chain rule to compute the first order derivative, which we need to equate to 0. This is the first order condition for profit maximization. So this is what you get. The first function here, which is multiplied by the derivative of the second, minus the second function, q1, multiplied by the derivative of the first one, which is minus 1. Okay, isolating q1 and solving, we find q1 being equal to this, okay, which is the reaction function of firm 1. Here we are in a game of quantity competition. Okay, so everything is expressed in terms of what the firms choose, which is the quantities. Okay, so the firm's best response function here can be interpreted as follows. It tells firm 1 which quantity q1 it has to choose to maximize its profit for any quantity q2 that firm 2 could choose. Okay, now the main difference with the case of price competition is that this reaction function is downward sloping. The slope is negative. Okay, if you take the derivative of r1 of q2 with respect to q2, you find minus delta over 2, which is negative. Okay, so in words, it means that if firm 1 expects q2 to increase, the reaction of firm 1 will be to decrease its quantity. Okay, so in a sense, the quantities, these strategies here, are moving in opposite direction. And this is why we talk of strategic substitutability. If you remember, the prices in the price competition game were strategic complements. Here is the opposite. The quantities, the decisions of the two firms, are strategic substitutes because they mutually offset one another. Okay? In more technical terms, we see that if firm 2 increases its quantity, then the marginal profit of firm 1 decreases. Okay? This is, I'm not going to re-explain all this, I explained it for the price competition, but this is in mathematical terms what is said here, and we find that this cross second order derivative is negative. Okay, so what is the intuition behind this? Again, imagine that I am firm 1, and I'm asking myself, what should I do? Which quantity should I choose for whatever quantity the other firm may choose? Okay, now imagine that I expect the other firm to increase its quantity. So the other firm is putting a larger quantity on the market, right? Meaning that what is remaining for me will be smaller. I mean, what is sometimes called the residual demand, the demand that will come to me once firm 2 has served the consumers, this residual demand becomes smaller. So it's as if I was facing a smaller market, okay, and naturally I will set a smaller quantity because I'm facing a smaller market. Okay, so the profitability of increasing my quantity becomes smaller the larger the quantity the other firm is putting on the market. Okay, this is in words what is being said here. Okay, and this is equivalent to say that the best response function are downward sloping. This is what is represented here. If Q2 increases, the reaction of firm 1 is to decrease Q1. Okay, so we've got a negative slope. I've drawn this for a given value of D. What happens if D decreases? Well, the slope is going to decrease, the negative slope is going to decrease, meaning that the reaction of firm 1 becomes less sensitive to the quantity of firm 2. And at the limit, when the products are completely differentiated, we find that the reaction of firm 1 is insensitive to the quantity of firm 2. This is the case of a local monopoly. Okay, and by the way, if you go back to the presentation about price competition, you would find that this is exactly the same. There is a horizontal line that we had also in the price competition case when the products are completely differentiated. Okay, now for the next steps, it's also the same as in price competition. We are looking for the Nash equilibrium, which is the intersection of the two reaction functions. Okay, so you can derive the reaction function of firm 2 exactly in the same way as you derived the reaction function of firm 1. So please redo this by yourself to make sure you understand correctly what we've done. And then we look at a profile of strategies which are mutual best responses, which is to say that we solve the system of two equations in two unknowns made of the two reaction functions. And this is what we've done here by substituting the reaction function of firm 2 into the reaction function of firm 1. I'll let you check that I haven't made any mistake. And this is what we find. Q1 star is the equilibrium quantity of firm 1, and Q2 star is the equilibrium quantity of firm 2. Okay. Now, the difference with the prices that we computed at the equilibrium of the price competition game is that quantities, they decrease with the cost of the firm and increase with the cost of the other firm. Okay, which makes sense again. If I'm firm 1 and my cost decreases, I'm more efficient, I can produce more. Okay, and if the other firm becomes less efficient, so if C2 increases, I'm in a position to produce more as well. Okay, because, see the previous slide, the strategies of the two firms, the quantities, are strategic substitutes. Okay, just to make sure, what is the effect of cost? Here what we do is to compute the difference between Q1 and Q2 at the equilibrium, and we see that this difference is proportional to the difference, to the opposite of the difference in cost. Okay, so how do we read this? If C2 is larger than C1, so if firm 1 is more efficient than firm 2, it has a lower cost, then firm 1 will produce a larger quantity than firm 2. Okay, so the firm with a lower marginal cost produces a larger quantity at equilibrium, which is to say that it has a larger market share, and you can check that it will also have a larger profit at equilibrium. Okay, so that's very intuitive. Okay, and we also need to check the conditions on the cost to make sure that both firms stay on the market. Okay, so here, assuming that C1 is lower than C2, well, what is the condition for firm 2 to stay on the market? It has to be able to produce a positive quantity at equilibrium. And if you use the expression of the equilibrium quantity of firm 2, you have this condition here, which can be reinterpreted as follows. It simply says that C2 cannot be too large with respect to C1. Okay, so if a firm is way too inefficient, so much less efficient than the other firm, then at equilibrium, it will just leave the market. It's not able to produce a positive quantity. Okay. Right, so this is the graphical interpretation of the equilibrium. We've just superimposed the reaction functions of the two firms. Again, we've done it for different values of D. If D decreases, we move in this way here, and you see that the equilibrium moves upward. So this is the opposite of what is said here. Is if D increases, so if we move this direction, the equilibrium quantities decrease. Okay, so when the products become more substitutable, when they are more closer to one another, then the equilibrium involves a smaller quantity for both firms. Okay, there is more competitive pressure and then translates into lower quantities for each firm. Okay, now as we did for the price competition, it's interesting to look at what happens when the firms are symmetric, when they have the same cost. We've done the computations here. You can review them at your own pace. And for future analysis and comparison, we just note the profit at equilibrium in the quantity competition case as being this expression. And you see that the profit decreases when the products are more substitutable. When we move from D is equal to 0 to D is equal to 1, you see that the profit is decreasing. D is equal to 0, that's the monopoly case. D is equal to 1 is the case of homogeneous products. And that's where the profit of each firm is the smallest, simply because, I repeat, when products are less differentiated, when D is larger, there is more competition between the firms. Right, so what we can do now is to extend this model to more than two firms. I'm not going to detail everything here. This is again something you can read at your own rhythm. I have detailed all the mathematical steps. I will just sketch this here in a few words, but I repeat, you can read this on your own. Okay, so there are any number of firms. N can be larger than 2. And we still continue to assume that they have a constant marginal cost, but this marginal cost can be different from one firm to another. So we use Ci to denote the cost of firm I. To simplify here, we take the product being homogeneous, so D is equal to 1. We need to introduce some notation. I just raise your attention on this notation here. Q minus I is the total quantity produced by the other firms, but firm I. Okay, so Q being the total quantity, the sum over all firms. If you just subtract the quantity of firm I, you have the quantity, the total quantity of the other firms. Okay, and we do the same to denote the costs. Okay, the sum of the marginal cost of all firms is C, and the sum of the marginal cost of all firms but firm I is C minus I. Okay, now how do we find the equilibrium here? Well, it's the same steps as before. We need to derive the first order condition of profit maximization in order to express the best response function of each firm. We've done it here for firm I, okay? And then we need to solve a system of n equations in n unknowns. Okay, so the Nash equilibrium is the intersection of the n best response functions of the firms. How do we do that? Well, we need some tricks, and this is basically what is explained in the next slide. The trick is to sum the best response functions over all firms. You will see the detail here. Why do we do this? Because it allows us to find an expression of the total quantity at equilibrium, and then we can use this total quantity to find the individual quantities, the quantities at equilibrium for each firm, and this is what is done here. Okay, so basically you find a generalization of what we had in the duopoly case, and let's just discuss this. The quantity of firm I at equilibrium decreases with its own costs and increases with the cost of all the other firms. Okay, it's also a function of how many firms there are in the industry, which is n. Okay, so I don't want you to spend too much time on this, but if you don't understand exactly how we arrived to this, all the steps are detailed here, and you can read this at your own pace. Now what we do here is just compute the equilibrium profit by computing first the price at equilibrium and then multiplying the margin, the price minus the cost of firm I times its equilibrium quantity, and this is this expression here. Okay, now this it's interesting to see what happens if all firms have the same costs. So if Ci is equal to C for all firms, then you have for the profit an expression which is simpler, and also for the quantity and for the Lerner index. Remember what the Lerner index is? It's the ratio between the difference price minus marginal cost divided by the price itself. It's our measure of market power, if you remember. Okay. The only thing I want to stress your attention on here is that all these expressions, so quantity of a single firm, the profit of a firm at equilibrium, and the Lerner index, it's very easy to see that they all decrease with n. So if you increase n, this is decreasing, and the Lerner index is decreasing as well. What does it mean from an economic point of view? It means that if you compare two industries which differ just by the number of firms, while the industry with the largest number of firms will have at equilibrium lower profits for each of these firms and a lower market power. Okay, so as you increase the number of firms, you decrease the market power of each of them. And at the limit, if you let n tend to infinity, this Lerner index would tend to 0, which means that when you have a very large number of small firms, which is perfect competition, the market power goes to 0. Okay, so you can see this model of quantity competition or Cournot competition with symmetric firms as a continuum going from monopoly, n would be equal to 1 in that case, towards perfect competition and going to infinity. Okay, and in between you've got the oligopoly, which becomes more and more competitive as the number of firms is growing. And this is all I wanted to tell you about quantity competition. We will, in the next presentation, compare price and quantity competition, but you already have all the elements to do this on your own. Thank you for your attention.